Well, good evening, everyone. It's a pleasure for me to announce the next lecture. We're going to be briefed about mobile phone call encryption by Lee Honeywell, the asterisk guru, and Paul Wouters, the VPN expert. Well, basically what they're going to talk us about is we all care about encryption when it comes to transferring our normal data, but when it comes to telephone calls, everything goes out in the more or less clear. Of course, there are crypto phones created by some companies using proprietary algorithms, not interoperable, you know the problems. And they have managed to build up their own system using open standards such as SIP for the voice communication and IPsec, L2TP and OpenVPN for crypto. And you have it. Enjoy.
Is this working? Excellent. All right, so we're going to talk to you, as you said, about mobile call encryption, basically voice over IP and IPsec on various mobile networks. So the slides are yours to copy. Enjoy. We just have to give credit to the lovely slide design by Michael. I'm not going to try and mispronounce that. And overall, we're going to go over the goal and design for what we were doing here. How to build a secure PBX, as much of an oxymoron as that may be, building a secure phone, and the trials and tribulations of hacking on Linux phones. And then we'll have a question and answer, and tomorrow we're going to be doing, is it 2-hour workshop? 1 hour? 1 hour, hour and a half, who knows, workshop about the different stuff we go. We're not really doing, there's no config files in this entire talk, so we'll be doing all that stuff tomorrow. So we start with the problems of current mobile phones. As our introducer there said, you know, we try and do encryption on any sort of, anytime we're using a public AP, anytime that we are concerned about the possibility of somebody accessing our data connections, and then we have important personal conversations over a cell phone network that is basically in the clear for all intents and purposes. I'll get a little bit more into the, how much the PSTN is also in the clear, but the cell phone networks in particular are pretty interceptable. You have stuff like lawful interception in the States, it's CALIA, in Canada it's whatever the RCMP wants to do. I don't know what the different laws are over here, but basically any telco that has public telephone numbers has to be able to give access to law enforcement to be able to intercept all of the phone calls that goes through their network.
And the person just sitting there quietly in the corner is the one who broke the GSM encryption, so he can tell you why it's all plain text, really.
Yeah. So Paul has done some work on how secure the Dutch tapping rooms are. It's one thing to have a tapping room that has access to all of the country's telecom infrastructure. It's another thing when once you've set up that tapping room, you don't control access to it properly. So I think we've got some links at the end to that, or we'll put some in the slides in the final version. I don't know how many of you have heard about the SIM card cloning issue, but there's a telecom magnate in Canada named Ted Rogers who runs Rogers Communications, which is our unfortunately only GSM provider. And someone cloned his SIM card and was running up $50,000 a month bills on a cloned SIM card because, you know, Rogers roaming rates are something else. And because the card was cloned and Ted didn't want to give up his phone number, and they just sort of let it slide. There's been a couple of issues too where people have had their cards cloned and their accounts haven't been turned off, and the accusation against the mobile providers is that they base whether or not they cut off your cloned SIM card on your credit history. So if somebody runs up $100,000 in roaming charges on a cloned SIM of yours and you have a really good credit history, they'd rather take your home than cut off your GSM access. So that the SIM card cloning thing is a pretty big problem right now. The price of GSM towers and scanners and other tools for intercepting GSM conversations as basically clear as Paul was saying, sorry, I didn't catch his name there. Lucky has cracked GSM. It's not a particularly strong encryption standard anymore. And stuff like setting up rogue towers is going to be an increasing problem. But, you know, 10 years ago, the equipment to intercept a GSM conversation was in the hundreds of thousands of dollars, and then it dropped to the $50,000 range. And now it's under 10. So if you have a reason for wanting that kind of equipment, you can get it, and it's not unobtainable anymore. Then there's the question of what backdoors or vulnerabilities are in our phones. You were saying that the Dutch spy agencies don't think that the BlackBerry is secure enough. There was a couple of BlackBerry exploits published at Black Hat last summer, or was it DEF CON? And then we'll get into the whole Linux phone thing shortly. But and then there's just the question of price, like 15 cents an SMS. I don't know how much the rates are around the world, but I mean, for me to use SMS on a roaming connection from Canada over here is getting towards $1 Canadian a message, and it's ridiculous. So.
And it's also now that I'm like, just give me a show of hands. Who's now using more than one SIM because they're not in the country where they normally live? So that's not too bad. Okay, so I'm now carrying like 4 SIMs, and I'm getting really tired of that too.
Just for comparison, who's here in a country that they don't normally live? So about a quarter of the raised hands have a different SIM card, which is like, that's ludicrous. There used to be, in Canada, there used to be two GSM providers, and the one smaller provider had peering agreements arranged with all sorts of carriers around the world. So were I to go to the States and use my Fido GSM phone, it was 25 cents a minute to roam. Like, that was fantastic. And then I had the unfortunate experience at DEF CON this summer of getting a $150 phone bill because when Fido got purchased by the larger GSM carrier, Rogers, they jacked up all the prices to over $1 a minute. So lack of competition, you know how that goes. So we've got the standard GSM cell phone connection. You go from your phone to the tower, through the cloud, to another tower, to another GSM phone. What happens in that cloud? Your guess is as good as mine. And like by guess, I mean we know that lawful access is enforced. If you're in a country whose infrastructure you don't know about, there could be all sorts of other stuff going on, whether it was industrial espionage, other kinds of government espionage. There's all sorts of considerations as to what's going on in that telco cloud. This is just for a voice call. As to what's happening if there's a data call, we've got all sorts of different potential proxies and servers that your call, whether it's voice or that your data call could be going through, whether it's a BlackBerry Enterprise server, some sort of proxy server. A number of CDMA providers, in particular in North America, tend to not like giving out public IP space. So you need to ask for, they call it a VPN compatible data connection, which really means they give you a public IP address. So, which is why you basically can't do a proper data connection on a couple of the providers in Canada. Like, you just don't get you're just going through a proxy for the entire connection. And these are all points of vulnerability for your conversation that you have no idea what's being done with your voice or your data. So our goal with this project, and we'll go into how much we achieved and didn't achieve of it later on, but the goal was to build a secure private communication infrastructure that can be used in untrusted hostile networks, whether it's telco or internet, because we do talk about voice over Wi-Fi in a bit, without losing any functionality compared to using a mobile phone or laptop. We wanted to use only trusted open source software, and we wanted to move the trusted aspect of the communication into the software we controlled, as in the open source software we were using, since we can't really trust the hardware, whether it's our snazzy Linux phone here or your Windows Mobile PDA phone or any of that. We're looking at a future where everybody's going to have a cell phone, whether it's their one laptop per child laptop that's going to have a GSM connection in it, or whatever the next generation is. And these are design considerations for that communications infrastructure that people are going to be deploying in the future. So what can we trust? Not a whole lot out of what we've gone over so far. You can't trust your voice call, whether it's a GSM call or whether it's a landline call. I mean, I'm sure that most of you know that it's as simple to tap a landline call as it is to walk up to somebody's house and clamp on with a butt set and listen to their conversation. Or, if they've got an old cordless phone and they're talking over that. Baby monitors, like how well that works. We can't trust our mobile phones because we have this infrastructure that I've gone over is like not, you don't know what's going on in the cloud. There's also a number of questions with mobile phones over whether or not whether or not somebody like a telco could turn on the microphone in your cell phone remotely without you being able to control it, and whether or not you'd be able to detect that with something like those stickers that show when there's a GSM connection, or when you put your mobile phone by a speaker and it makes that beep 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 if it's a GSM phone. There's even situations where if that call is happening and that secret call is happening and you're near enough to a tower that they've overpowered the tower, so they don't need to, they use a very, very low powered connection on your cell phone, you may not even be able to detect the fact that your phone is making an outgoing call without you knowing it. This is all conjecture, but it's all completely technologically feasible. The actual IP network that you're using on a GPRS, UMTS, or what was the other one? Anyway, the Edge, the GPRS Edge or UMTS connection, you can't trust whether it's going through a BES or like a proxy server, any sort of, you're on the cloud regardless. And then you have the question of proprietary phones. You don't know what's on your Windows mobile phone. And I mean, that's always been my concern with the crypto phone, is that it runs on Windows Mobile. I totally respect the crypto phone project. I think it's an amazing product, but it does run on Windows Mobile. And then we get into unknown and homebrew cryptography. You just don't want to go there. So who do we want to protect against? I've gone over a lot of this already. It's internet eavesdropping, telco eavesdropping, revealing location information. I was talking to one of the guys from the EFF yesterday who's working on something around this, but we didn't go into this at all. You're on a cell phone. Within a couple of feet, they know where you are. What the best, cheapest method of communication is, if Wi-Fi or WiMAX is available, you want to use that. And if it's not, you drop to GPRS, Edge, UMTS, getting more expensive, in some places less so, in some places more so than others. In Canada, it's $100 for 100 megs. And that's the best you can get. You don't want to use untrusted third-party storage or relay services. There's a couple of encrypted VoIP services out there that have different, have untrusted relay services. I'm thinking of, was it Wango? I had some concern about the Wango project and relaying through, and of course Skype is the big example of that. You have, it's closed source. They prevent you from even looking at the application through a debugger. There's nothing you can do there. And storage and relay services like SMS, BlackBerry servers, BES, commercial email services like the ones that the different cell phone providers offer, and their internet services. Do you have some more that you wanted to say there?
Well, everybody knows what happens when these services are either they can be mandatorily tappable by governments, or you can get like the Paris Hilton effect, where you can get her phone numbers and all her messages. So you really don't want to store this on anything that's not under your own control.
And then there's issues like spam and SPIT, SPIT being the unfortunate acronym for spam over IP telephony, or misconfigured that voice over misconfigured IP telephony is the other one. The acronym spells out vomit. These are, so we haven't so much gone into stuff like preventing unwanted calls and messages, but based on one of the potential designs that we've cooked up, that could actually be a nice little side effect of what we're doing, because we're preventing most calls, including all the unwanted ones. So infrastructure that we can't trust, the plain cell phone voice network, the cell phone data network, you're basically on the internet, telco and network proxies, and commercial services offered by vendors. So, commercial SIP. One thing that's really important to remember, I don't know what the legislation is on this side of the pond, but certainly in North America, if you have voice over IP termination for a regular, for a phone number, so not sort of the voice over IP to voice over IP services like free world dial-up, but if you have something like, I'm trying to think of provider names, but anyway, you have some sort of SIP or IX, any of that PSTN termination, they are legally obliged to conform to the same lawful interception laws as any telco is. They may not have complied yet because they just might not have built their infrastructure to do that yet, but CALIA legislation in the States and the equivalent in Canada, it's all on the books, it's just that they haven't started enforcing it in all cases yet. But it will come, and it will come soon, so just because you're going from voice over IP to your personal asterisk server in your house to your voice over IP phone in your house, don't think that you're not subject to legal interception.
Actually, in Europe, there's already the ATSI standards and the transport over intercepted IP traffic. So there's already standards to do internet tapping. And if you move from voice to VoIP, basically you're just moving into another realm of tapping. But all the laws there and all the most of the infrastructure is there now as well. Like Siemens is one of the big German vendors for interception capabilities in various telecom equipment, including everything that can do voice. VoIP.
Ironic that. So we've gone over all the things that you can't trust. So what can you trust? Well, the only thing you can really trust in this case is stuff that you've rolled your own of. So your open source OS on the phone, we'll get into the trials and tribulations of that shortly, your own open source PBX and VPN and IAM servers, and your own open source applications for each of those services on the phone, whether it's SIP or IX or another voice over IP protocol. Your own VPN, whether it's OpenSWAN, IPsec, another IPsec implementation, OpenVPN, and then IAM applications. One thing that's really important to remember about IAM applications, we're not talking MSN, Messenger, or AIM, or Yahoo, because those are all going through a central server. It's got to be something like Jabber that is a non-centralized instant messaging system, because otherwise you're just defeating the whole purpose by having a plain text connection to somebody else's server. So, and yeah, refusing to use a fallback, having your own trusted infrastructure. If this is an absolute must that you have to have this secure communication, don't use a fallback because you open yourself up. So the problems of running our own PBX server, you can't really hook it up to traditional phone line or even, as I said, a commercial SIP or IX to POTS provider. Just in case anybody isn't clear on those acronyms, PSTN, POTS, they mean the same thing. They mean landlines or cell phones. Plain old telephone system, publicly switched telephone network. Probably all knew that though. It's pretty impossible to secure complex VoIP products natively. The basic overall recommendation from the major vendors, from the IETF with regards to SIP, from the people who wrote IX, is the best way to secure this is to put it over VPN. You can do a couple of different things. There's authentication for both the SIP and the IX protocols, but you want to put it over VPN because these authentication protocols are not intended to do peer-to-peer authentication. They're intended as a server-to-endpoint infrastructure using certificates and like that style of authentication. They're not intended for me calling someone on a SIP client or an IX client and there being encryption there. You want to trunk it over a VPN. The other problems that you run into when you're running a VoIP server are information leakage via VoIP. You've got your presence status that can be seen using SIP. You have stuff like directory harvesting attacks that are sort of, it's basically the same thing as having finger running on a mail server. Somebody can just run through every possible name and find all of the email addresses, find all of the SIP extensions or IX extensions. You're storing lots of sensitive information on that PBX, like voicemails. I don't know how, I've never quite understood why people get so worked up about voicemails, but I know that in a lot of industries, people save their voicemails ridiculously, like you get transitioning old PBXs over to new ones, and people have hundreds of voicemails saved in their mailboxes, and they're like, it's a really serious emotional attachment to these voicemails for some reason. And then you get lots of bogus incoming information. There's a huge problem with insecure PBXs, voice over IP PBXs in particular, and so there's a lot of scanning that goes on. So if you are running a PBX that is in any way identifiable as a PBX from the internet, even if it's completely locked down, you're still going to get a lot of garbage information thrown at you. And a lot of garbage calls, although that, it's picking up slowly. The spit problem, it's not a huge problem yet, but it will be. It totally will be. And yeah, that's the IETF recommendation, wrap your VoIP protocols in VPNs, and a lot of people seem to be following that, but there's a number of fun and challenging Google hacks involving like Cisco PBXs on the internet. So. Problems of running a secure phone. This is sort of the flip side of the coin to running a secure PBX. You've got an unknown piece of hardware with potential backdoors. Even if you're running an open source phone, we'll go into this later. There's the standard configuration for an open source or Linux-based cell phone is to have two processors. One processor is running the Linux OS, and the other processor is running some mystery unknown embedded OS. And the Linux part of the phone, the Linux processor or process, has serial access to things like the radio and the GPS and the microphone often. And then there's this closed proprietary OS that has the actual access to the hardware. This is done for fairly reasonable reasons, in that there are regulatory issues around cellular cell phone power and output and interference with other phones, that kind of thing. So that's why they're doing the closed, the embedded part and then the separate OS level part that you have access to. So again, as we said, there's no free access to the hardware. Then you get stuff like the OS just being vulnerable if you don't know what it is or if it's Windows Mobile. You have the whole separate issue of the portability of a cell phone, which is part of its usefulness, but also a bit of a danger when you have that phone stolen from you and now somebody has access to your whole address book, all of your information, and the ability to make calls as you. So don't store your pins in a speed dial or anything. It's just your voicemail pin in a speed dial. My dad did this once. I got really mad at him. Anyway, you have unknown and untrusted voice over IP applications running on this phone if you're using it as a Wi-Fi phone or whatever. There's not a lot of them out there, but you can run SIP on your Windows Mobile PDA, and that's sort of what we're talking about there. So do you want to take over for it?
So now we talked a bit about the PBX system and a bit about the phone. Now about the layer in between, which is the connectivity. There's different ways you'd want to have your phone connect to a network, and of course, ideally, you want a high-speed network. And if that's not available, you'll fall back to a lower-speed one. And actually, this phone is like a dual phone. It's got GSM, but it also got Wi-Fi. So if the Wi-Fi here is up, somebody can actually call this phone. The Wi-Fi hasn't really been up today much, I noticed, so this phone's unavailable, but it also has a GSM, so you can call it on its other number, and then it's just a normal GSM phone. So what are we looking at? We have Wi-Fi and WiMAX, which if it's available will be your best bet. It's got high bandwidth, low latency. It tends not to be too mobile. If you walk away, you can't reach your neighbor's network anymore, or your own network anymore. Hopping between networks is often not as reliable either. If you go from one access point to the other, even if they're set up to be one big network, it doesn't always work.
The hopping between networks with a voice over IP connection is so flaky as to be impossible. It's just not even worth trying.
Yeah, remember, if reconnecting takes you 1 or 2 seconds, your conversation will be severely interrupted. We're hoping to get some more data later when Toronto Hydro fixes their network, so we can actually do something with it. But at this point, like Toronto Hydro has basically rolled out a complete one big, large, I think 5 by 3 kilometer network in the downtown area. So basically the whole downtown area is now covered in Wi-Fi, except you can't even use a web browser on it, so I'm not even trying the phone yet. It's pretty broken. And so far there aren't that many phones that actually have Wi-Fi. It's beginning to show up in the newer XDAs, which are way too expensive, but in other phones. So maybe one of these new Linux-based phones will be cheap enough to actually have Wi-Fi. So if you do that, then you're not using the telco. The telco is pretty expensive anyway, so if you can get free Wi-Fi from the air, that's preferable anyway. Your fallback option will be GPRS or the successor of GPRS called Edge, which is supported on the newer phones. The bandwidth is pretty low, the latency is pretty high, and I must say, I haven't used GPRS in the last, I think half year or year or so, but when I was using it, a year ago in Amsterdam, it was pretty bad. Even just running SSH was pretty impossible. Of course, with SSH, you have the problem it's very interactive. You hit a key, it sends a packet, it waits for a packet to come back. When you hit another key, so the latency really eats you up there. So GPRS is not the best, but it's doable. I'll show some graphs in a bit where we can see that it is doable, even though it's not ideal. UMTS, it's not that different from GPRS, except you get more bandwidth, but really we don't need more bandwidth. The bandwidth is sort of enough if you go with a lower codec. So sure, with UMTS you could use a better codecs, but you still have the high latency problem. What the cryptophone has done to solve this problem is that they're actually making a modem call, like an old-fashioned voice call, and then you hook this acoustic coupler on the line, and you make it turn into a digital signal. So they're doing a voice call, so they're getting their guaranteed bandwidth over that. So it's low latency and. I stand corrected. Okay, but you do get a dedicated slot, unlike GPRS, right?
And it's not on the offsite.
Okay, we will fix these slides. The cryptophone's cool. So if we look at GPRS, the theoretical bandwidth is about 40K down and 30K up. One of the problems of the telco and IEEE in general versus the IETF is that the telcos have decided that they need to do a guaranteed delivery. So if some packet transmission is lost, they will keep the packet, and because they actually also want a in-order guaranteed delivery, they will keep all the other packets they already have until they can resend that one packet, and then they will resend everything else. This is completely different from how the internet works. The internet basically works if we send a packet, and if the other end cares and missed it, then they'll let us know and we'll resend it. And if this happens, if it's going okay, then we'll send some larger packets, or we'll send packets faster. And if we get more dropouts, then we'll slow down again. So this whole dynamic bandwidth sending that the internet is using works much better than this guaranteed in-order delivery where you're stalling. If I'm talking over, if I'm doing a voice conversation with somebody and I've dropped a few packets, I'd rather have that they miss one word than that they're stalled for 15 seconds and then have all these retransmitted packets and hear the same word every time. So death to OZ, yeah.
Important thing, we're talking a lot of packets here. There's been a number of problems with the Linksys WRT routers that everybody loves to load firmware on, where you tried to put a SIP connection over one of these routers and it would reboot the router because it just couldn't handle the number of packets you're trying to send. So that's the guaranteed in order delivery thing is a huge problem for what we're trying to do.
So having that problem, if we're using UDP like OpenVPN or IPsec, which is sending ESP packets, we'll get these duplicate packets because they will be sent. The upper layer will assume that they're dropped and you might resend them. And they will also be resent by the telco network. So we'll get multiple layers trying to resync the connection which is like really horrible for your performance. It gets even worse when you're using TCP, because you get the whole TCP handshaking and SYN-ACK packets in there as well. And the guaranteed TCP delivery, like certain UDP protocols like SIP itself can drop certain packets and you can still continue the call. But if you're using TCP, then every packet has to be delivered. With GPRS, the round trip time of like 1 second is nothing abnormal. So again, this is a problem if you're talking, if two people are talking and they're having a very short sentence conversation. Hi, how are you doing? I'm fine. Okay, so how are you? Yeah, that's great. Oh, excellent. Every time you switch per person, you'll get these delays, and they will be really buggy. If you're like me now, presenting with a long monologue, then it won't matter, because if the packets drop, you'll just don't hear me for a while, and then I'll continue talking again. So this is what in the old way was called push to talk, where you actually had to push this button and then you could talk, and then you would say over and you would release the button. So if you're if you're using GPRS, you're very likely have to sort of change the way that you're talking to the other person on the line. Another thing, GPRS uses spare time slots in your service. So if it's New Year and you want to call your mom over your super secure phone, then
Or you're in New York.
or if you're in New York, then forget about calling, because everything will be overloaded, and the first thing that goes is the free GPRS cycles on the cell. Another thing, cell hopping really doesn't work very well. In my personal experience, if you're in the middle of a downtown big city and you take the train and you start your GPRS connection, because in the downtown city area the cells are really small, if you're sitting in a train, the only thing you're doing is reconnecting to a different cell. You're not getting any data through. You're just reconnecting, waiting for the next hop. By the time you're ready to send data, oh, oops, end of cell, next cell starting, so we have to hop again. As soon as you leave the city and the cells become bigger, you actually get some data through. So, but in practice, it really means if you're hopping in a network, it's not going to work as well as a traditional phone call. I'm not sure how the crypto phone, does it have problems with this as well or not? You can sit on a train in Berlin and leave Berlin and keep talking. Okay, so the crypto phone has the same problem, except it reconnects faster than GPRS, so their gaps are less noticeable.
It's important to note that generally speaking, if you've got 150 milliseconds of delay in a conversation, it starts to get noticeable, but it's not too bad. That's what you'd sort of experience on a crummy Skype connection. You hit 300 milliseconds and it starts to become difficult to communicate, and you have to start moving to that sort of push to talk mode of communication where you do your little, you give your spiel, you stop, you say over, the next person goes, you wait till they're done, the next person goes. Like over 300 milliseconds it starts to become annoying, so.
So some people did some serious research over the GPRS bandwidth delays. So even though the title is practical experience with TCP, they actually also did UDP and raw packet statistics. So these are the statistics of 64-byte UDP packets. I'm not sure how visible it is in the back. Basically, it's the delay versus the amount of packets that went through. So basically what they did was they kept the GPRS location stationary. They made sure they had good radio conditions, and then once every 5 to 10 seconds they would send a packet, and then they would see what the packet delay was. And as you can see, the uplink is pretty good, like between 0 and 1 seconds, basically almost all the packets go out. That it would sort of mean that talking on your phone will work pretty well. If you look at the graph on the right, the downlink, you can see that it becomes more and more normal that packets take longer than 1 second, and it's even not uncommon for them to take 2 to 3 seconds. So again, this is where you basically have to go to push to talk and keep your talking simple, use monologues, and don't expect too much interactivity from your phone call. Bandwidth-wise, this shows the throughput you can get on GPRS. On the left, the uplink, you can see that even with poor link condition, with poor link conditions, you're gone at 0.4 kilobyte per second. It's just not going to be enough to have a phone conversation. The same for, I guess, 1.4 for an uplink. I think should be enough. It should be enough if you use a very low codecs with a very poor quality.
If you were to use Speaks or G729, I'm pretty sure you could get through on those even with the even with the VPN wrapper.
Right. And you can see that the downlink is not so much of a problem because you're always up in the 4 to 4.5 kilobit range. So how are we going to secure our calls? Well, we sort of already expressed that we like IETF standards and protocols. So first, we must secure the voice calls by making a data connection. We also want to have alternatives for things like SMS or MMS, and things like internet and email services that people have on certain phones, like BlackBerry. So we'll need to decide on a VPN technology that assigns an IP address to your device, because we don't want to use separate encryption mechanisms to secure all these different things. We just want to have our phone have one new internal IP address, and then it will use that IP address per default and then only use encryption, because then the firewall rules on our mobile phone become really easy. Only allow VPN traffic and nothing else. That means that you cannot leak any information by accident. There's only going to be VPN traffic to your VPN server and nothing else. So we're not going to use any homemade crypto. It's somewhat of a lie because we are using OpenVPN, but I'll get back to that. We need to be able to work in badly designed telco networks, and trust me, most networks are really designed badly in the telco world. They don't really do internet or IP networks very well. You'll see weird packet sizes. You'll see a number of layers of NAT devices. You'll see certain packets with certain ports being lost for no reason. Weird ICMP messages. These networks are really, really dirty. So you'll have to break through it. Sometimes they also on purpose will firewall certain things. We have to go around these firewalls as well. Most people don't realize it, but the reason that Skype is really the most popular default client people use is because it can break out through almost any network there is. It's really good at that. So we need to get some of those features back without, falling into proprietary protocols. And we want the solution to work basically on all platforms, on mobile phones, laptops, and PDAs, because I might want to use my laptop as my phone connection when I can. And also, today we're developing for this phone, and I don't know, tomorrow this Chinese company goes bankrupt or sold or whatever, and they make another phone. Hardware really cycles really fast, and since most hardware needs some hacking of one certain kind before we can actually use it, we want to make things at least, some independent of the hardware we're using, so that we don't have to reinvent the wheel every time a new phone comes to market. So don't make any VoIP calls, only use internet traffic, only use a VPN, run our own operating system, run our own IAM. This is all we've already said before. So this is what our design basically looks like. You have your encryption call from your GSM, goes through the telco cloud that you don't trust but you don't care about anymore because it's only a VPN, goes to your VPN server, and behind that there's a PBX which supports everything you want. If you want, you can reroute the PBX to landlines or other SIP providers, depending on the model of trust you use. We'll come back to that as well. Of course, the VPN server and the PBX and your IM server and your mail server could all be one and the same server, depending on what you want or how big your network is or how many people you need to support, how many phones. If you look at it from the IP layer, the clouds actually work pretty well. Okay. In this case, we picked 10.01.0/24. That's the network on the right. That basically has our VPN server with behind it the other servers. The phones that you see on the left, they get a public IP address. In this case, I called them A.B.C.D and E.F.G.H. Those IP addresses are only used for VPN communication. So they set up the VPN, and then through the VPN you get a new IP address. And you notice that it's in the same range. It's a 10.01 address for both of them. So logically, these phones now appear in your own local company network or home network. And so they will be able to reach each other. So what VPN technologies do we use? As I said, it's really crypto is really difficult. Making your own crypto is really not advisable. The problem with the IETF protocols is they're really clear protocols and everybody knows how they work and they're pretty safe, but they're easily blocked because everybody knows that if you block UDP port 500, nobody will get an IPsec connection through anymore. So we need to work around that. So on the left, we can see IPsec with LT2P. LT2P is the Microsoft way of tunneling an IP address within a VPN. We decided to use that because it's a standard that sort of works. Even though we don't use any Microsoft products, we are using LT2P for this. The alternative is XAuth, which is an old standard by IETF, or IGV2, which isn't really done yet. So this is a good middle ground for now. So IPsec, it's got a proven track record. It's military grade security buzzword compliant. Works everywhere. It's a standard. Has seen lots of research. It's got good performance. It's really bad to break through NATs. The Linux world is a bit of a mess with IPsec. There's two IPsec stacks that haven't been merged yet. One requires a separate patch for NAT reversal. The other one doesn't really handle various packet sizes very well. So basically, when you need to break through a NAT router, things get a bit ugly, and you have a better chance using OpenVPN. So getting back to OpenVPN, it's fairly easy to set up on the client side. It's a bit messy on the server because they're doing various networking hacks on the server to actually route these packets through. If you start to play with it, definitely use a separate server and make sure that your hands can physically touch the server when you're configuring it, because you will screw up and lose your connection to it. It's somewhat homegrown protocol, even though it's using OpenSSL for all the crypto operations. So the crypto itself is pretty trusted, but it's still sort of wrapped up in its own UDP or TCP protocol, which hasn't seen as much research. There's been a few vulnerabilities in OpenVPN, though they have been fixed, both on the protocol and the implementation level. So it's definitely a bit more vulnerable than IPsec is. We prefer not to use it, but we also realize that it has a much better chance of bypassing a firewall than IPsec has. So we basically want to use both of them. Try IPsec, and if that fails, we'll fall back to OpenVPN. So this is another mode where you can use the VPN. Let's assume that you're somewhere in South America and you have your GSM there. You set up your VPN. You don't trust the local place where you are, either the local government or the local big corporation competitor of yours. You can do a VPN connection to your PBX in your trusted country, where you know that the government doesn't eavesdrop on all of your calls. Notice that this PBX is in Canada, not in America. And from there on, you can then gate back into the traditional phone system and make an insecure call. So you're protected from the insecure area where you're at, like in this case, South America. And you're only vulnerable to the North American, eavesdropping police. which hopefully has better privacy laws, which Canada actually does.
As the slide loads, in this situation, it's more that you don't really care if we're considering here the possibility that you don't really care for whatever reason that your government has the potential to be eavesdropping on you, but you have concerns about the trustworthiness of the telecom infrastructure in a foreign country, and say you have an important competitor there, they could be paying somebody off in the telco to be allowing access to your phone calls. That's the situation we're going over here.
But do also take note of that, even in a quote progressive pro-government like Holland, you have military intelligence officers clearly stating that the economy is a national interest and needs to be secured. So this basically justifies things like, eavesdropping on, what was it, Airbus versus Boeing, where Echelon was used, and I guess France or Germany also tried to spy in on the Americans, and some large bit went to Boeing instead of Airbus, just because and this is like governments using their infrastructure to help their own big corporations, because money is national interest. You need to, if your government has no money, you'll lose your security. So it's not just the paranoid people that are trying to get you. It's just justified by money. Okay, so by now I'm looking at the cryptophone people. I see the cryptophone people heavily looking at the slide. So the cryptophone, as far as I know, only does cryptophone to cryptophone call. Now, there's software as well, so you can use your PC. But it doesn't have the flexibility of calling into a PBX, where from the PBX you can do other calls. So this is one feature we like. We can go to a PBX and then we can make SIP calls, or we can go to a POTS line and make a normal call. So you can you can protect yourself from the local area that you are and make a secure call to a trusted area and then go untrusted from there. But that's okay because you trust that area. Okay, this is where I take off.
So we're using Asterisk as our PBX, wrapped up in the lovely Trixbox distribution, which Trixbox is quite the kitchen sink of Asterisk. It even includes, as you can see from the slide, Sugar CRM, because you got to have CRM on your PBX on the same machine. Anyway, the advantage of Trixbox is that it takes about 20 minutes to set up after you've clicked enter at the install. We're now going to go into Firefox. And so, yeah, Trixbox.org is where you can get it. From the main screen, you log in as your administrative user, and then you get the admin interface, which is FreePBX, which is another open source piece of software that sits on top of Asterisk. The Asterisk configuration files can be a bit tricky, so it's nice to have a convenient web GUI if you want to just do like simple, a couple of extensions and a POTS line. It's really, really convenient to be able to set it up in 20 minutes. To get Trixbox working initially, you have to install a few modules. The new 2.0 version comes with absolutely nothing installed, even like the main API and application, like the core application. So to get anything done, you have to have the core, and I can never remember which one else. I'm pretty sure you just need core to have like a couple of extensions, but you might as well add stuff like conferences. None of these are things that are gonna, if you have a PBX that's behind a VPN, none of this is stuff that's gonna put you at risk in any way because it's behind a VPN. If you were wanting to put this machine on the internet to be able to receive calls to SIP user at myasterisk.org, you would want to be very careful about what you're installing on your Asterisk server, and you definitely wouldn't want to use Trixbox. There's too many random web apps installed on it to want to use it on the public internet. But for the model that we were looking at with having it behind a VPN, it's not as big of a deal, and it is really convenient. So then, yeah, just a simple process of setting up an extension. You go over to the extension menu, add extension gets you this form, but without stuff filled in, and then you go through. All you need to include is the secret, and you have to change the type to friend for an end user for a SIP client. You can also do, there's a couple of different, depending on what you're using for your endpoint, you might also want to use a different kind of extension, like, and the internet's not working. Yeah, there's a bunch of different extension types that you can add to your Trix box, whether it's one of the other voice over IP protocols. With a bit of hacking, you can even get H323 working if you really want to. But SIP, EEX, and PSTN are the big three. So EEX is the inter-asterisk exchange. It's the homegrown protocol that was originally designed to trunk asterisks together, but you can also use it to endpoints. It's a little easier to get through a firewall, whereas SIP, firewall or NAT, whereas SIP has all these like complicated problems around. Basically, the stuff that you had to deal with FTP years ago, you have to deal with all that again with SIP, because it sets up a UDP stream on a high random port. So that has its own difficulties. So yeah, we basically, for what we wanted to do here, we just had an asterisk set up with a couple of extensions. It's pretty simple. So yeah, and then we'll get into so many phones and so few of them worked. So we started out with this whole giant collection of potential phones that, had the processing power, the IP stack, all the stuff that we needed to be able to do what we wanted to do, which is in and of itself a fairly simple proposition: voice over IP over VPN over a cell phone connection of one type or another. So we ran into the first thing. A lot of them run proprietary operating systems, so we counted all of those out. And now the reason that the various XDAs are still up on there is because there's a fairly large project in the works to get Linux running on the XDA platforms. They've had a fair bit of success so far. They can boot the phone, and they can even make a GPRS call on the phone. That's pretty much it. I don't know how long they can even keep the GPRS connection up for, though.
I think the XDA is pretty good.
The XDA is working pretty well? Yeah, so. They're pretty expensive, so that's why we never got one of them. But they're neat phones, and you can run Linux on them, sort of. So yeah, we eliminated those because they're too expensive. We left the green phone on here, even though it was slightly over our too expensive mark, because it was really cool. But then it wasn't available. They had a GPL problem with the bootloader, so. Yeah, and then we'll get into the whole GPL problem with this thing. But yeah, so we were left with the Para Wireless Hippie, it's called the Hippie, and the Motorola A1200, and we had this Zeltis Wi-Fi phone on here, which we didn't bring with us. But yeah, and this one, we didn't initially think it runs Linux, but there's questions now. So, and then the Zeltis, you can't get the source code. So, and then with the Motorola phones, both with the A1200 and the earlier A780, which you can sometimes find it, but it's been discontinued, so it's a little harder to find. There's this interesting problem that I mentioned earlier with having the two processors, and there's a watchdog, and it uses SE Linux and just shuts down the phone. So do we? Oh, yeah. Actually,
are any of the OpenEZX people here? No, Stefan Smith? No? Okay, I guess not. Okay, they've been working really hard in the last month to get their own Linux kernel running on both the A780 and the A1200. The A780 has the problem where the proprietary CPU shuts down the entire phone if it doesn't get a proper signal from the open source CPU, and of course they're still hacking and seeing what signals to exactly send, because they're proprietary binaries, so they needed to find out the proper kernel drivers and the MUX clients to talk over that serial line and send the right signals. Last I heard, but I sort of lost contact with them a week and a half ago since I started traveling, was that they managed to have the phone no longer shut down after 30 seconds. So hopefully they're getting better. The problem is, though, with the A780 is that for practical purposes it's not really available anymore. It's like a discontinued phone, so you have to find really sleazy dealers, or I guess eBay, to find it. The problem with the Motorola A1200 is that it's running SE Linux, so it's using the SE Linux mechanisms to basically, keep you locked out of your own phone. Apparently, the SE Linux version of it is like a year and a half old, so or even older. So there are ways of probably hacking through the SE Linux, but we'll see that there's a move to somewhat more open source phones. So whether these phones are still going to be used in half a year, probably very unlikely, at least not on a massive scale. So the XDAs, they do run Linux, they're very expensive, not all the device drivers have been supported on them, but of course the cool thing is the newest XDAs do have like a Wi-Fi and a GSM on them. So if you got the money, it's going to be nice. But we really want like, a $150 phone that everybody can use, and not like a $600 XDA.
With the XDAs, you've also got the fairly significant chance of bricking your phone. They are Windows mobile phones originally. They also, I don't think they've made very much progress with getting the Wi-Fi working under Linux. It's the GPRS connection, and they haven't got any voice calls done on them at all. They're having trouble getting access to the microphone. So they've had luck with GPRS and not the Wi-Fi or voice.
So these are the phones we started working on. The Zoltus more or less because we had one anyway. I've actually forgot the Zoltus, so I can't show it to you, but I'll tell you a bit about it. It's pretty big, and when I heard that Linksys was going to come with the what they call iPhones, which are basically also Wi-Fi only phones, I think they might be much more interesting. So I'm not sure if they run like VxWorks or Linux. Was that the 15-minute warning or the 5-minute warning? What? 25. As in 5 or 15? 5. Okay, let me race through the slides then. Okay, so let's skip that. So this is briefly the Zoltus firmware format that we found. Basically, there's a string, there's a rootfs, there's a gsub kernel, there's some checksums. We found the string Monta Vista Linux in there, so it's a Monta Vista 2.4.21 kernel. If Harold Welt is around here, I would love to hear why they haven't been sued yet by GPL violations, because basically almost all the GPL violations of Linux kernels seem to be coming from Monta Vista. I guess he won't answer publicly, but maybe privately. Please find me and tell me why this is. So we found the rootfs, the firmware versions in there. It's got BusyBox, glibc, which funnily enough is not used because all the apps are statically linked. It's got the entire phone application in WIP, in a binary called WIP2, and it got a mini GUI called MP4 Web. And there's what looks like a sound driver in there. So we know pretty much about this firmware. We tried modifying it and then having the phone updated. The phone's still rejecting it. So we're doing something wrong somewhere. There's not many bytes left unaccounted for, so hopefully we'll figure it out. And Willem, who's also worked on the cryptophone, has been a great help analyzing all this firmware. So thank you, Willem. So for flashing, you need to have, let's just skip this. If you want to flash it, read this. There's some weird things with the phone. Same with the Parawireless. It seems to be running something called HOpen, which is some sort of Chinese telco nationwide new real-time operating system, which seems to be Linux cut with a few functions. It also runs one big binary called W, which seems to be an entire phone application. It's using Linux file systems and C shells and other things. They don't call it Linux, and the vendor is calling this a proprietary Linux OS. And for $200,000 I could get a license for it to develop for it. Hopefully we can change their mind. So there's 7 executables we found: the shell, a GDB server, MK-DOSFS for formatting your external card, and the X-modem upload download protocol, probably for flashing. So what are we adding to the phones? Well, read through the slides. We found a command line zip client that is really useful. It's called PGSUA. Supporting everything we want. It's got a very small footprint and we've got some calls working with it. So hopefully we'll be able to put that on the phones. Jabber, there's some Jabber command line clients that we want to add to basically replace SMS. And some scripting that needs to be done once we get there. And well, this is slide 42. Well, this is basically the end. So if there's any questions, please ask them right now. I'm not sure if there's microphones in the room.
Yeah,
there are. Okay, go for
For
it.
the German market, there is a SL75. Better? Oh yeah. Okay. For the German market, there's a Siemens Gigaset SL75 WLAN, which runs Linux. The source is available. You can flash it once because you don't get the utility to flash it again. And yeah, I've never found anyone who has hacked it yet.
So Gma Gigaset, that's not a DECT phone?
No, that they have Gigaset line, which are DECT phones. There is a DECT phone with a SIP client on the base station, and the SL75 WLAN is
Okay.
a SIP phone.
Okay, we'll look into it. Great, thanks. There's a phone waiting somewhere, a microphone waiting there?
Excuse me? Have you had any latency problems when using VPN? So maybe because of the processors of your cell phones are too slow, or even with normal laptops?
In general, these CPUs these days are fast enough to do crypto operations without causing any delay. The delays are really the latency in the network and not the crypto operations.
Did you consider using a separate box?
Right, okay, right.
Did you consider using a separate box and use your phone only as a modem, so to speak, and have them communicate with Bluetooth?
No, I don't want to carry my laptop all the time. I want my
No,
phone to
I'm
be a
not talking
standalone
about your
unit.
laptop necessarily. It could be any device that speaks Bluetooth.
It's an idea. We're trying to get this to be fairly device independent. That it's basically going to be an application that runs on anything that can run Linux or anything that can run IPsec and a SIP phone. But that is a good idea, and it's something worth looking into, I think.
Sorry, could you be please quiet when leaving the room? We are still having some. Just a quick comment, in your network diagram you had set up a bridge from the mobile phones to the VPN server. Aren't you afraid of getting problems with broadcast storms or broadcast traffic? Wouldn't it be better to use a routed environment from the phone to the VPN server?
To use what? To use what?
A routed environment, so routing between the subnet, the network you have your PBX and IAM server sitting in.
Well, you basically make the phone appear on the other end. So
yeah, you're using the bridge mode, so you're bridging through the because you had the mobile phones in the same IP network as
Yes.
your PBX and the
yeah,
other.
but you can make that your own dedicated
Okay,
subnet
so
for
it's
phones, right?
not
So
your-
10.02 could be all your mobile phones, and 10.01
Okay,
could
it's
be all
not
your servers.
your
It's whatever you want. The VPN gives you the flexibility to design this how you want.
Okay.
In the last year, a lot of phones switched to the Series 60 from Symbian. How is it about security on this Symbian operating system? Because for Linux, there is, for example, in Austria, I cannot buy one Linux phone with UMTS and Wi-Fi. So how is it with this series related to security and SIP and with this stuff?
I'm hoping that OpenMoko will be a really nice phone that's coming soon. That's Linux friendly and runs Linux, and you get all the source code and the same with the Green Tech. The Green phone from Trolltech. So I'm hoping we won't need to start hacking Symbian phones. I'd really like not do that.
Sorry, which was the first phone you told?
Sorry?
The first phone you recommended?
The OpenMoko phone, it's a Linux phone. It's currently vaporware, but we're hoping to get one soon.
Okay, thanks.
Basically, my advice for phone at this point would be wait 2 to 3 months and see what's on the market, because things are really happening right now.
I mean, the green phone did ship a couple of units. Like, it's not vaporware. They just had a GPL issue. They shipped a couple of units, realized they had this issue, stopped shipping.
Yeah, but the green phone was only like a development project for companies, not for a private user, not.
No, well, yeah, you had to say you were a developer and then you could get it. Actually, I ordered it, I paid for it twice, they canceled the credit card transaction twice, and the last email I got was on December 26th saying that they're continued shipping again. So, I don't know, maybe there's a phone for me waiting.
Okay.
So I have to be online all the time with my phone? Or how do you, you had this phone on the left side and the one on the right side?
So if you're on GPRS, you're basically always on. It's like your BlackBerry. You're continuously online.
And if you have a VPN, you're always transmitting data. So
To be reachable with your SIP client or EEX client on your phone, you would need to be online, and there would be a certain amount of cost in data sending like packets all the time. But both SIP and EEX are fairly efficient at that keep alive, so it wouldn't be a lot of data. I mean, this is going to be an expensive proposition no matter what. Like, I don't think we've done exact calculations, but I wouldn't be surprised if it was in the $10 a minute range.
I sort of like calculate, if you start using only like GPRS only and you're able to do all your voice calls using data to your own PBX server, which has like a SIP provider, then if you're calling for 70 euros a month, it's going to be cheaper to buy the highest GPRS connection bundle, which will give you unlimited traffic. So it will work for a few months until they maybe realize that you're actually doing more than what they consider unlimited traffic. But future will tell us when they cut you off. But basically, yes, you will have to max out your GPRS subscription. But if you actually do 70 euros of mobile phone calls a month, you will break even. This is calculated in like what I did with the Canadian prices, which are a bit high. Things might actually be a little bit better here in Germany.
Canadian data prices are ridiculous. You can't get an unlimited connection. It's really, really annoying.
And the problem with the limited GPRS subscriptions is that as soon as you go 1 byte over, they basically want your soul. Like the prices of going over your allotted amount of megabytes is like, you might as well kill yourself.
And don't forget that we're running a workshop tomorrow, so I guess we're going to probably have a lot more time to answer questions and to talk about configurations and that kind of thing there. I think there's one more question if we've got time for it.
When you're doing this workshop tomorrow, you've pointed out that there's only a very limited number of phones which can now be used for your application. Do you bring any phones with you to show up how this thing can be done?
We're going to be discussing probably more about how difficult it was to get a phone to work on this for this project, but this is the hippie phone, the Para Wireless. It's the one, as we were talking about, that runs Hopin, a proprietary Linux-based OS. And there's a couple of other ones out there, but we just haven't been able to get a hold of any of them. So.
But it actually works pretty well. Like I have, made phone calls from and to Holland using this phone. Of course, without encryption because that's not what they support. But that's the next step.
When the Wi-Fi was working, we were registered with Access for All's SIP provider. So.
Okay, so if people want to know more details about configuration files of OpenVPN or OpenSON, LTTP or Asterisk or whatever, tomorrow there's a workshop. Drop by and we'll show you everything.